Hello guys, and welcome back to 5-Star Physics. In our last video we talked about scalars and vectors and the quantities that fall under them. And at the end of the video I also talked about how we could look at these quantities in graphs. Well, this video is going to be focusing on graphs and a new quantity that we call acceleration. First, we got to look at graphs. Graphs are going to be your most important friend. And as you're going to see in the future, graphs is just another way to speak about physics. There's multiple ways. Like, for example, you can explain physics in words. You can demonstrate it with a graph. You can solve an equation to show it. There's a lot of different ways, but graphs I always found were the easiest way to visually represent what I wanted to talk about. And so today we're going to be talking about the different types of graphs and the quantities of their area and their slope. So first, let's just draw out a graph here. And on our x-axis, we're going to put time. Time is always going to be on our x-axis, most of the time. Just for now, for kinematics, time is always going to be on the x. And on the y, for this one, we're going to have delta x, which is displacement. So this is going to be a displacement versus time graph, or position versus time graph. It's also important to know that you have to mark your units. This is a little small here, but squeeze that in. M is for meters, and S is for seconds. Your physics teacher may try to trip you up and change your units, but it's very important to know that physics is always in meters and always in seconds, never in hours, never in kilometers, never in feet, never in yards. Really important to know that it's only in meters. So let's start with a delta x versus time graph. So let's just draw a constant linear line. Don't have to worry about curves or anything of that sort. So now let's take a look at the different quantities. So first let's look at the slope of this line here. Slope is y over x, rise over run, right? So we just have to replace y and replace x with our quantities that are on the x and the y. So delta x over t. But wait, this is exactly what we talked about in the last video with average velocity. So does that mean that the slope of a position versus time graph is velocity? Well, if you were thinking that, that is correct. The slope of a position versus time graph is velocity. It's really important to know that because on a test, you may be given a position versus time graph and they may ask you, solve for velocity on this graph. And the way that you would do that is just by finding the slope. Now, for this one, we don't have a quantity of area. And this is because delta x is going to be the farthest down that we go. Delta x doesn't have a representation in physics like velocity does. It doesn't have something over time because position is just position where it is in the system. So it has nothing to do with time, and so for this case we don't have another graph. But I want to also look at a velocity versus time graph because this one is really important. So again, let's just draw a graph, right? And time, again, always going to be on the x-axis with seconds. And this time, like I said, we're going to put velocity on the y. And remember, if it's delta x over t, then its units are what delta x units are, which is meters, over what time's units are, which is seconds. So velocity is meters per second. So again, we're going to draw a constant line. Now, again, let's take a look at the slope. Well, the slope is delta v, right? So velocity over time. But wait, what is velocity over time? I mean, that's not, we've only talked about position and we only talked about velocity. What could that possibly be? This is something that we call acceleration. And acceleration is pretty much how your velocity is changing over time. Velocity is how your position is changing. So that's how it relates. And that's why if you're asked to solve for acceleration, you're just going to find the slope of the velocity versus time graph. And it's also really important to note that acceleration does have direction. Acceleration is a vector. It is not scalar. And it's really important to know that, as we'll see. But also, we have to talk about the area under this graph. Well, the area under this graph is just going to be velocity times time, right? So delta VT. What would that equal? Well, if we know that V is just going to equal delta x over t, then if we were solving for position, wouldn't it just be Vt? So if it's Vt, then this is just going to equal delta x, and that's right. Area is displacement. So it's really important to know, and I'm just going to erase this here, but this is what you should really know. And this is what I'm trying to get at here, which is pretty much the fact that slope is almost a way of going forward. So I always thought of it kind of like as an order. It goes delta x, then delta v, then acceleration. And the way to solve for each one is by finding slope. So finding the slope of delta x, you get v. Finding the slope of delta v, you get a, and so forth. Although this is the farthest that you will go in AP Physics. Acceleration does have a slope, and its slope is something called the jerk. However, we don't really talk about it. It's never really mentioned, and not even in Physics 2 or Physics C, so it's really not important. Area is just a way of going backwards. So it's the same thing like this, except now you're going from acceleration to velocity to delta x. So I always thought of differentiating. So slope forwards, area backwards, and it's important to know that. Now, you can also think of this like as an equation, because like I showed you before, if you multiply time by delta v, like to get the area, it would take the denominator of the equation of delta x, right, over t. You're kind of just like taking this denominator out and moving it over, so you're kind of solving for delta x here. But I just like to think of it more simple, like area backwards, slope forwards. Something to quickly keep in mind when graphing points on a graph is your line of best fit. Your line of best fit is just the average of all your points, but it doesn't have to go through all the points. You would think in a regular graph, you have to go from dot to dot to dot, so you would think it would be like a curve like this. But for your line of best fit, it has to be straight. And so straight is just going to be the average of all your points. It's also important to know that your line of best fit does not have to start from the origin. And actually, it shouldn't. So the average line here is going to be just a straight line going right through the middle of these points. You can see that it's very close to this point and these 3 points here. And that's the main aspect of your line of best fit. I briefly mentioned acceleration before when talking about the slope of a velocity versus time graph, but I want to go a little bit more into depth. Acceleration is just a vector quantity, and it just measures how your speed and your direction are changing. This is represented by this equation shown here, where it says that average acceleration is equal to the change in velocity over time. Now, velocity can increase if acceleration is going in the positive direction, because acceleration is what is causing you to speed up. But if acceleration is going in the opposite direction of velocity, then that's something called deceleration, and in that case, the object is going to be slowing down. Its velocity will be decreasing. It's also important to note that acceleration cannot be fast or slow, and it should not be described that way. It can either be a big or a small number. You will not say acceleration is fast or acceleration is slow. You will just say acceleration is great or acceleration is small. There are 3 main things that I want you to take away from this video. The first having to do with graphs and the quantities that have to do with them. So if you were to go from a position versus time graph or displacement versus time graph to a velocity versus time graph, remember that you have to find slope. So think of slope as going forwards. Now if you have to do the opposite and go from a velocity versus time graph back to a displacement versus time graph, I want you to think of that as area. So think of slope as forwards, area as backwards. That will be necessary to know, especially in the AP exam. I also want you to think about the line of best fit. Remember that it is the average of all the points, not just a line that goes through all the points. It does not have to start at the origin, and how I like to think of average is the same amount of points should be above the line as are below the line, to the best of your ability. The last thing is acceleration. Remember, it is a vector quantity, and if it is going in the same direction as velocity, velocity is going to increase. If it's going in the opposite direction, velocity is going to decrease, because it measures how velocity is going to change over time. Please tune in for our next video where we're going to be talking about using all of these quantities and equations and how to solve. Thank you guys for tuning in.